this group?
These are totally different than us, so.
Oh, okay.
We tested, I guess, erosion when we really think about it. We said, how does water travel through soil and how does water travel through pebbles? We put on the pan, we put one side dirt or soil and one side gravel. We poured at the same time, and what we noticed was the dirt traveled farther across the pan, the soil did. And we related it to that things with like a larger mass, it would be harder to erode because it would take longer and more force to carry it. And we also said that a contributing factor was how dry the material was, because we noticed as the soil got wetter, that it traveled more.
Oh, okay. Okay, from another group or something.
Application.
Oh, just how, I don't know if you've seen that like before and after picture from that outdoor thing. And so it's like how, you know, in 2040 or something, like what New York City's gonna look like, how, because of the erosion and stuff. Anybody seen that video?
Yeah, I know. Yeah.
Okay. Everybody's just like,
So erosion, it might take a while, but it does carry things fairly far.
Even if you think of like seawalls, like how they have to build seawalls and they're using like a cement material, because if there wasn't that, then, you know, the water could like, you know, freeze. And so it obviously makes it a little harder if there's a seawall there. Okay, this group?
Okay, our question was, how does water travel through sand, soil, and gravel? So we tested them separately. And we said that the sand would absorb. We thought that with the soil, it would absorb a little bit and then go to the bottom. And then with the gravel, it would just travel through to the bottom. And then we got a little creative and we put sand and then soil on top. And it was kind of cool to see because we used that little cup to pour it in. And
we measured the amount of water, so like each cup got the same amount too.
to see like how long it would take for the water to travel to the bottom of our cups. And
Comparing what? Comparing a cup of sand with a cup of sand and soil?
No, we compared all four of
All
them.
four, okay.
And we only did it with like one, like, I guess you could say shot of water each cup.
Okay, one shot of water.
Yes. So we did that, I'll take over. We did that, we did that initially and found that the sand, it stopped, like the sand stopped the water. The pebbles obviously took in most of the water. The soil absorbed all of the water, and then this one, the mix between the two, did kind of both. It waited a minute, but then it started like bubbling, and then slowly went down.
So comparing the sand with the soil, with what was the main difference?
The sand didn't absorb as much water as the soil and the pebbles.
Oh, so soil absorbed faster.
Much faster,
Much
yeah.
faster.
I mean, the soil absorbed the whole thing, like all of the water to the drop, whereas the sand absorbed only like maybe a fourth of the way. So we had to do like 3 or 4 more of the waters to get it to absorb the whole way. Mm-hmm.
So the bottom of the sand and stuff stayed dry until you continue to add the.
Yeah.
This group up here. What's your question?
Our question was, what Earth system allows water to travel the fastest? So what material would allow it to go fastest? We took a cup and we filled it, or we layered it. So we had the reptile bedding on the bottom, and then the rocks, dirt, and then sand. We thought that sand was, we pretty much thought the first 3 would go the fastest, and then we weren't sure about the reptile bedding, so we kind of came to a conclusion that it might go slower than the rest of them. So when we poured the water in, the water immediately went through the sand, and then it hit the dirt, and it like came to an almost stop. And it took its time going through the dirt, and then once it hit the rocks and the reptile bedding, it just went right to the bottom. We let it sit for a little bit, and then we did it again and poured the water in again to see what would happen. And what we found was similar to what they discovered is the wetter the soil got, the faster it went through. But the wetter the sand got, it slowed down. So it took a lot longer to go through wet sand than it did dry sand. And we thought because obviously it's more compact and there's a lot less space through wet sand, that's why it slowed down. So that's about it.
Now, did you notice, you said like after the first time when it went through I'm trying to think of the first two, the sand and the soil,
Yeah.
and then when it went right to the bottom, did you like notice it after you like added the water, did it eventually absorb back into that bedding?
It eventually, when it sat for a while, when I looked at it, I was like, oh man, the water's in there. I just thought I put way too much water in it, but it
Okay.
eventually just came and sat there. Oh yes, it did do that.
Okay.
You were right. Good job.
So like they said, it kind of like absorbed, like where when you pour the water into the sand, like it kind of can absorb as it goes down, but that reptile bedding kind of acts the opposite, like it absorbs, like
Yeah.
almost from the bottom up, like it goes right through.
That is a good one.
Okay, the last one.
Well, we first wanted to do what the water would taste like after we run it through fresh material, but after the first one, we decided to change it. So what we inquired about was which type of earth or land will the water travel through the fastest. So we took our cups and we poked 4 holes in the bottom of each cup, and we measured the same amount of earth for each material and the same amount of water, and we poured it through, and we predicted that the water would travel through the gravel, the rocks the fastest, and we were correct because we're smart. And it took 1 second for the stream to go through the gravel and start leaking out of the bottom, and it came in a steady stream. And then we ran it through the eco dirt, and it actually didn't come out at all. It it just absorbed all of it. And the dirt, it took 7 seconds for it to soak through and start coming out of the bottom, and it only came in drops. And then the sand, it took 9, or did I say sand already? Did I say dirt or sand? Oh, dirt, it took 7 seconds. The sand, it took 9 seconds to go through and start dropping out of the bottom. So we were correct. And the real life application is, I suppose, why sand is like involved in like when they make like dams and stuff to block water, like through rivers and all that kind of stuff. Why sand is involved in the cement mixture and keeps the water out. And if I decide to live in an aquarium, that the eco dirt would be the most comfortable for me to sleep on. Just,
How did the water taste?
it was quite interesting, but I don't recommend it, and I did not want to do it again afterwards. So quite sandy.
Really? You really did that?
Yes. It's all.
No.
So, in conclusion, next week, say do not eat the material.
Yes,
Yeah.
yes,
Yeah.
I'll make sure I put that warning
Okay,
label on. So we did kind of similar to what some groups did. Some of you had either did what we did and did it a little differently, but one of our inquiries. So we did kind of like what Megan's group did. We did how does water move through the different layers of the earth, but we actually used one of these big trays and kind of like did the layers like you did in your cup, and then we actually kind of used elevation to determine like to add the water and see how it absorbed and see like what water was left over at the bottom. And then we found that the water would move through the layers of sand, gravel, and soil. So similarly to what you guys found, you know, it moves through the gravel obviously the fastest. The sand and soil starts to slow down, but then, you know, by the end, we put the eco earth at the bottom, so we kind of knew what was gonna happen, but, so really there was no water left beyond the eco earth, because by that time it just kind of had absorbed in there.
And then our second one was what happens when you add water to different earth materials. And this is like when you put one of the groups did it, when you put the cups, like each material in the cups and saw how it went down and what happened. And so this was our guesses. We guessed that the sand would absorb a little, the eco earth would absorb the most, soil would absorb a little, and then the gravel wouldn't absorb any or the least, and that's pretty much what we found out too.
Yeah, I think the sand did absorb a little bit more than we expected, but yeah.
And then this last one is kind of similar to the one we just talked about, where it was how does water move through earth materials. So we used the big tray again, and we did them all separately. We didn't layer them, and we used elevation again and poured the water through to see if it would travel to the bottom of the pan or if it would be absorbed or how, what the water would do. And so for the sand, we found that the water would move through it with some of it being absorbed, so you could see where it was like expanding through the sand, but some of it just trickled right to the bottom. The gravel, it went all the way to the bottom of the tray, just right through it. The soil was pretty similar to the sand. Some of it got absorbed, but some of it went through. And then the eco earth, the water was completely absorbed. So that was
It did take a couple minutes for this one though, I think, like a lot of the groups have said.
that was what we did.
Okay. Okay, so what we found when we did our reflection in our elementary book club was a couple facts that help relate was when it rains on land, some water soaks into the ground and some runs off the land into rivers, lakes, and streams. And water wears down rocks and carries tons of sediment to the land, to the ocean, or from the land to the ocean. An interesting fact that one of the groups found is when the flow rate of a river is at its highest, it's in flood stage, and when it's at its lowest, then drought prevails. A couple of them found that models, pictures, written information, and diagrams were shown in the book to help students understand this. Also, one of the books was set up like a news article containing real-life interesting facts. We said some of the misconceptions that students may have about this topic is confusion on the types of rocks and how they are formed, layers of the earth, and that the world is actually hollow. So some of the books offered helpful ideas to instruct students by using drawings to illustrate ideas, pictures related to science ideas, such as, you know, when they were talking about gems, it actually looked like a treasure box. And they used animals throughout the illustrations, even if it didn't actually have to do with what they were talking about. The next group, they showed their claim how water moves through earth materials. A couple points in the book was water erosion moves through the earth, picking up rocks, mud, and sediment. And another one was water is the most powerful erosive force on earth. They showed different examples of glaciers, water in geysers. A couple science ideas they found interesting was that ice in the form of glaciers is a power blaster of all weathering forces. And they said water skin can be made by students to view insects hanging from water skin and see sediments carried by the water flow. So they were saying that you can actually use this net to observe the different layers of water. You know, you see the insects on top and sediments, you know, underneath the surface. And they wanted to use the analogy to convey this idea to their students by comparing raindrops to a lot of tiny hammers hammering on the Earth's surface, because that's kind of how raindrops are. They said they would pose the question of, you know, what do raindrops and hammers have in common, and then go from there.